Students, so this guided note-taking assignment that you're going to be doing for topic 5, I'm going to try and help you out with it a little bit if I can. So the document, it looks like this, all right? So you can do it a couple different ways. If you have a printer and you find it easier to print it out, you can print it out and fill in the blanks as we go. Or if you don't have a printer, then you just have to type in and basically just adjust your document accordingly and then submit it to me. If you do decide to print it and submit it to me that way, then you're going to have to scan it and attach it back to me in the designated area there on Google Classroom, whichever you find easiest. So what I'm going to do here is I'm going to go to the textbook and I'm going to go to the textbook and I'm going to read through some sections, basically exactly the document that you have there. I'm going to read through those sections and you can fill them out as we go, or if you find it easier, you can just not listen to me and you can just go through the textbook yourself and do the work on your own. But this is for those of you who prefer to have a voice as well. Hydraulic systems use the force of a liquid in a confined space, such as an oil pipeline. Hydraulic systems apply two essential characteristics of fluids: their incompressibility and their ability to transmit pressure. Pneumatic systems do not seal the gas, usually air, in a mechanical system in the same way that hydraulic machines seal in hydraulic fluid. Usually the air passes through the pneumatic device under high pressure and then escapes outside the device. The high pressure air may come from a machine that draws in outside air and compresses it. Hoses then carry the high pressure air to the pneumatic device. Let's go to pneumatics at work. Pneumatic devices are used all around us. A common example is the jackhammer. Bursts of air under very high pressure drive a part called a chuck in and out of the jackhammer at high speeds. Resembling a very large screwdriver, the chuck pounds the rocks or concrete into fragments Staple guns and pneumatic nailers use pulses of air pressure to drive staples or nails into solid objects. Sandblasters do exactly what the name implies. High pressure air blasts tiny sand particles out of the nozzle. Sandblasting is an excellent way to remove dirt and paint from stone or brick. Medical engineers have developed a type of cast filled with pressurized air. A solid frame with a balloon-like lining is fitted to the injured leg. High-pressure air is pumped into the lining through a hose. Because the air pressure can be controlled precisely, the cast can be made to fit snugly and securely. In a hovercraft, powerful pumps draw in outside air and pump it out through holes in the bottom of the hovercraft. A skirt around the bottom holds in enough air to support the weight of the craft above water or land. Given enough air pressure, a hovercraft can support extremely heavy loads. Propellers drive the hovercraft forward, and rudders are used to steer it. Hydraulics at work. Did I skip through? No. Okay. The machines contain tanks filled with hydraulic fluid and pumps that generate pressure in most hydraulic equipment. The energy for pumping is supplied by a gasoline engine or by an electric or by electric motor valves. Hold on. Yeah, we're on the right place. Sorry about that. Valves direct the high pressure fluid through steel pipes to the parts of the machine where the pressure of the fluid is needed to generate large forces to lift or to dig. Often the steering and braking systems in large machines are powered by the high pressure hydraulic fluid as well. Hydraulics in flight. When an airplane taxis along a runway, the pilot steers the plane using the nose and the nose wheel. During takeoff, the pilot may lower the flaps to make a turn while airborne. The pilot moves the ailerons up or down and adjusts the rudder to keep the plane level. The pilot adjusts the elevators. Landing a plane in a multi-system process. The pilot uses hydraulics to lower the flaps and slats to slow the aircraft during the approach before landing. The pilot then uses hydraulics to raise the spoilers when the aircraft touches down. The spoilers prevent the wing from lifting the aircraft again. Every mechanical system is powered by hydraulics. What happens if all the systems fail? An emergency air-driven, let's go on here. What happens if all the systems fail? An emergency air-driven generator dropped out from a door in the bottom of the plane. This generator resembles a fan. It has a propeller that spins when outside air strikes it. Since jets travel at tremendous speeds, the air turns the propeller extremely rapidly. This rapid turning motion generates alternative power to supply the hydraulic systems. Hydraulics and pneumatics in your body. The respiratory system in your body is more complex than any pneumatic machinery. This system is made up of lungs, tubes that allow air to enter and leave the lungs, and muscles that cause your lungs to expand and contract. Breathing depends on changes in air pressure. When you are breathing normally, your muscles make your lungs expand and draw in about 500 milliliters of air. Simply relaxing will push the air back out. You breathe in and out about 12 times per minute. When you are active, you breathe more quickly and more deeply. Your body also depends on a complex hydraulic system. Blood must be kept under pressure so that it can be pumped to all parts of your body. Your heart is the pump that moves blood through the blood vessels with pressure that rises and falls. Each time your heart beats, it exerts a force on your blood and pushes it along. Your heart can pump nearly 4 billion times without stopping, and it can circulate a total of 500 million liters of fluid. When blood leaves the left ventricle, it travels first through arteries, then capillaries, and finally veins before it returns to your heart. The diameter of the largest blood vessel in your body is just under 2 centimeters. The smallest vessels, the capillaries, are less than 0.0001 centimeters in diameter. It takes a great deal of pressure to push fluid through these tubes. It takes a great deal of pressure to push a fluid through tubes with small diameters, such as capillaries. Let's go on to valves and pumps. Pressure is transmitted equally throughout a fluid. We are on page 324 here. That's correct. A valve is used to control the fluid. A valve is a movable part that controls the flow of a fluid by opening or closing. Your heart is actually two pumps which circulate your blood throughout the arteries and capillaries in your body. The heart uses 4 automatic valves to circulate the blood. Let me just make sure we're on the right page here. No. Yeah, okay. I'm going to start that over. Your heart is actually 2 pumps which circulate your blood throughout the arteries and capillaries in your body. The heart uses 4 automatic valves to circulate the blood. Blood pressure increases and decreases between heartbeats. Immediately after the heart contracts, a surge of blood causes high pressure in the arteries. Then, before the next heartbeat, the pressure falls, only to increase again after the next contraction. All right, students, if you take your time and think about the information in there, that is going to cover everything that you need to know for your Topic 5 quiz that will take place on Thursday. Best of luck and happy studies.